होना चाहिए कि LSP चैनल नाम की
LSP in. Yeah, so we are live now on the YouTube as well. Yep, so we have gone live on YouTube, so anybody who is unable to join the Meetup can actually join to watch the YouTube channel. So that's up there. 13 members joined till now, so we expect more in another 10 minutes. So we'll wait for another 5 minutes and start the formal round of introductions. So for the time being, Niranjan, since you are the first speaker, would you like to just try to share your screen, that if everything works fine?
Sure, Devanshu. Is it visible?
Not yet. Yeah, right now it's coming up.
Yes, Niranjan.
Yeah, Niranjan, it's live now. Okay, now you can stop sharing, then we can get into it.
So I have multiple screens here, so can anyone confirm whether... Okay, it's the presentation that is visible.
The presentation is visible.
Yeah, we are seeing the scaling with Aurora MySQL.
Yeah, just that in the top of the screen there is slightly some blank space, so you can. Otherwise, it's okay. I mean, we are able to see it all good. So I think from that perspective, we are good. Otherwise, someone may ask something on the chat.
Devanshu, can you quickly post the link for the YouTube here in case somebody asks? We can hear it now.
Okay, let me try that.
Yeah, actually, just posting it on LinkedIn might also be a good thing. We can reshare and, like, if somebody is watching, they can just grab it.
Okay, I'm trying to paste it on the Slack. Just see, not Slack, the message of the meeting. So just see if it's visible. Good morning, Shruti.
Hey, good morning, Devanshu.
Yeah, just see if this is the link which works.
That may not be, actually. This is... No, hold on.
Safir, the YouTube channel should have the link, I think. Yeah, this may not be the right one. This is...
Yeah, this tries to open a player on the machine, basically, because the protocol is RTMP.
That's right. Yeah, so please ignore this. Can I delete this? No.
That's okay. Yep, we got it.
Okay, so Kuntal has pasted
Yes,
one. Thank you. Yeah, so feel free to share it. It should be, we should be all good. So we'll get into the intro session. We are roughly around 14-15 people now up, and more to continue to join. So yeah, so please feel free to introduce yourself, since speakers would introduce themselves during the session. So we'll go around table now. We'll start with Darshan. Darshan, would you like to go ahead, unmute, come on video, and introduce yourself, please?
Yeah, hi everyone. Like myself, Darshan. I'm basically a senior software engineer working at GridLogic Group. Yeah, I'm very happy to attend this session.
And
Thank you.
thank you, Darshan. We'll go next. Jiva, please.
Hey everyone, this is Jiva S. Chelladurai. I have written a few books on Docker. I ran an open source meetup, one of the largest open source meetup in Bangalore, but we are little not active. I'm the CEO of Common Consulting Service, where we work on a lot of software consulting related activities, right? So I will share my LinkedIn in the chat, and if you guys want to have a discussion with me, you can ping me on my LinkedIn and we can talk. Have a great day, guys.
Great to have you with LSP meetup as well, Jiva. So we'll
Thank you.
nicely catch you for further meetups and all. We have an author
Sure,
today. Great, nice to have you with us, Jiva. Thank you.
Yeah. Glad to be here. Thank you.
Yeah. So Kiran has joined, but Kiran is a speaker. So Kiran, in 30 seconds, would you like to go ahead and introduce yourself?
Good afternoon, everyone. My name is Kiran. I am having over 20 years of experience in databases. So today I will be presenting one of the use case of Samsung to complement the presentation which will be done by Niranjan. So that is my introduction.
Thanks, Kiran. Kiran works for Samsung Research, who's my past colleague. Kuntal, would you like to go ahead and introduce yourself, please?
Sure. Hello, guys. I'm Kuntal. I'm working as a tech lead with ULA. That's an Indonesian B2B startup. Before that, I have been working with Akamai Technologies and a couple of other companies. That's the very brief gist, and glad to be here to learn from you, to grow with you. Thank you.
Thanks, Kuntal. Nice to have you with us today. Nagaraj, would you like to come on camera, introduce yourself?
Hey, hi. I'm Nagraj, and I have a 16 plus years of experience, and I'm part of GridLogic Group as well, working as a principal engineer. Have experience on backend database and front-end as well. So happy to join this group, and I want to know more on the MySQL part. Thank you, guys.
Great. Thanks. Nagaraj. So I see Nikit Niranjan joined from a couple of devices. We'll go to Nishant. Nishant, thanks for rejoining the LSP for today's session. Please go ahead for a 30 seconds introduction.
Hi everyone. Well, it's a very good start of starting this Saturday with this meetup. My name is Nishant Dhiman, and I have been working in DMS, Developer and Mobile Services team in AWS like from last 3 years. So I'm from the same team as Niranjan, like AWS. Debanshu, Niranjan, and I work with AWS. Yeah, looking forward to learn from this event. Thank you.
Thanks, Nishant. Safir, the pro one, come up.
Hey guys, so my name is Safir. Associated with SP from the start, like it's almost 11 years now, right, Dibanshu?
10 years. We are into 10 years.
Yeah, this is the 10th year anniversary. Yeah, right. So yeah, it's been it's still exciting as like the first event. So happy to be here, talking to you guys, and it's nice.
Thanks, Safir. Shekhar Thota, did you join earlier? Shekhar, please introduce yourself.
Yes, Devansh. I'm the one first who have talked with you this morning.
Okay, great.
Morning all. This is Shekhar. I am also from GridLogic, like Darshan and Nagraj. We all three work for the same team. I carry 16 years of experience working on .NET technologies so far, and now for the past 3 years we are working on Flutter and with AWS as our hosting system. and MySQL, all these things. And first of all, I would like to thank Darshan to let know about this meet for me. Otherwise, I'm not even aware of it. Thanks for it, and very happy to learn from this group, and wanted to join these events like whenever you have this in future. Thank you very much.
Perfect.
And Jiva, yep. And Jiva, thank you very much for the LinkedIn link. I'll just go through and connect you back with you.
Yes. We have something on Flutter on our meetup, so definitely we can talk.
Yeah, fantastic. And Darshan and Nagaraj, they both are Flutter experts in my group, so we all can join with them. Yep. Thank you.
Let's do something great thing for the open source.
Sure. Thank you very much. Thank you all.
Shruti.
So, hey, good morning, all. Like everyone knows, my name is Shruti, and I'm part of WebScale Networks, working as a monitoring engineer. And I have like 3 years of experience, and this is my first LSP meeting. So happy to join and looking forward to learn something from here. Yeah.
Fantastic, Shruti. Fantastic. Nasir, would you like to come on camera with your outstanding background and then go ahead and introduce yourself?
The background credit goes to Google Meets. It's a live background. You actually see the dew drops and water drops on the glass plane there. Excellent. This industry for close to 25 years now. Currently with NVIDIA, I was with Yahoo for the past 10 years. Before this, I know with Devanshu and Safir and a few other guys from Yahoo Times. Before that, I was with IBM, with Sun Micro, with HP Compaq. So a long history. And I've been with LSP for quite some time now. Devanshu really miss that in-person get-togethers we used to have.
Yeah, the moment some host is ready to host us in person, we'll go for an in-person meetup site. So whoever is ready to host us in person, I would be ready to host it in person.
Sure.
If you guys are interested doing an extreme north of Bangalore, you can use my office. It is in Hennur Bangalore main road, but I don't know whether you guys would love to come all that way. Then our floor is open for you guys anytime.
I'll catch up with you, Jiva, for sure.
Sure. Thank you.
Okay.
Thanks a bunch.
Thanks, Nasir. Yeah. So 10 years now for this meetup. Vanishing Gradient. I like the nickname. Please come on the camera and introduce yourself, please. Vanishing Gradient. Somebody joined with a nick as Vanishing Gradient, which seems to
vanished.
He has vanished. Okay, so it's 11:03. So for the actually, we should wait for a few more minutes because the trend is people start joining after 11:15 when the first talk is listed from the organizers. Now today, from the organizers, usually we get Anshu, me, Srinivas, and all these guys. So Anshu has recently moved. So today it is not his normal time. He's not in IST anymore. So that's the reason we could see Anshu there, but he has created a backup. If my device fails, his device will stream this to YouTube. That's the intention, that Anshu is virtually there in the meeting, but he's not in front of a camera for sure. So when we started in 2012, there were hardly any meetups in Bangalore, and we felt an urgent need to create one with this name. Generally, this name is not very uncommon. So large-scale production engineering are terminologies used at Yahoo in some point in time. Then most probably this production engineering was predominant with LinkedIn as well. Then later LinkedIn moved to change their terminology to site reliability engineering. And then industry overall started moving to two terminologies, DevOps and site reliability engineering. But there are still few companies who says their production engineering as the job code says, like you build monitoring system, you build infrastructure, you build deployment pipeline and stuff, and that's how we all manage our infrastructure. So with the advent of cloud, a lot of things have changed, and you could clearly see that half of the work that standard production engineer used to do are taken care of by the cloud providers today. So some part is gone, but there is large number of additional parts which have come into the plate. The role becomes more and more complex day after day. So when we started, we felt generally there is very low perception, a very low understanding about how to operate distributed applications in a large infrastructure which serves millions of queries per second. So that was the primary intention. Today, we could see that with public cloud being available for most of us, generally this infrastructure scaling and stuff are taken care of. But here, with the advent of microservices and all, the whole domain has become more complexer. So it is not that production engineers or SREs or DevOps all the world are having less work now. They're having more work, more complex work to achieve the performance that their application deserves. So I think this meetup is still relevant. It has probably shifted a bit from its initial days, where it used to be largely associated with companies or need of the domain where people had their own data centers in place. So with this background of this community, we would move forward. So we are running this 10th event. When we started the 10th year, sorry, it's not 10th event, it's 41st event of the 10th year. So when we started our 10th year, we thought, okay, so let's try to get a couple of more events. We used to be quarterly. We tried to become bi-monthly in our 10th year. So this is the 5th event of the 10th year. The last event, which is the 6th event, will take place in March. While we were adjusting with the new norms of COVID, we have become remote. We have gone live in streaming and all. These are the improvements which has happened. And also one additional thing has happened because we went virtual. We had our colleagues from Sydney, Dublin, US able to join these meetups now because their time was still, I think, doable kind. So those speakers otherwise would have been an impossibility had it been like our physical meetup. So we are seeing a pros and cons of this virtual world as well. At the same time, we'll try to explore a mixed mode if it is possible. Say, a few of the meetups we go physical, and we can continue to have few of the meetups virtual as well. So that's what the organizing team is thinking around to take it forward from 11th year onward. And we would obviously love all of you to be associated with the group. We have a Tumblr page, we have a Meetup page. We need a lot more volunteers to run the show. So request all of you to get engaged in our Slack group, in our Meetup community, as well as in the Tumblr website and all. So with this, I think it's 11:10 now, and we are planning to start early because we have all three speakers with us. So we'll start a bit early. So that may give a little bit of disadvantage to the people who have seen that the first talk will start at 11:20. But I think that's okay. For the sake of time, everyone is busy. So we'll go 20 minutes earlier today. So we'll invite Niranjan, first introduce yourself. Yeah, Jiva mentioned in the chat that please share your social handles on the messenger link. Please do share those, your LinkedIn handles, etc. So Niranjan, it's back to you for the first talk. Please go ahead, introduce yourself and get started.
Yes. Thanks for that, Devanshu. Good morning, everyone. Thanks for joining this call. I'm a cloud support engineer too here in AWS Premium Support. I've been in this role for like around 4 years, and as the slide speaks, I have an RDS SME, RDS MySQL SME, and an Aurora Infrastructure SME here in Premium Support. So today, probably we'll start with the benefits of Aurora MySQL over your traditional architecture, and I'll even tell you how exactly Aurora is working at the backend, so that it's useful for you if you're gonna like use Aurora for your production workload. Yes, probably let's get started. Yes, this is the agenda for today. So I'll give you a MySQL landscape overview and how exactly the architecture is different in Aurora when compared to the traditional architecture. And I'll be comparing the performance and the cost with MySQL. And I'll consider one of the e-commerce example to help you understand the advantages of Aurora. And then, yes, at the end, we'll have Kiran speaking about the Samsung Pay migration to Aurora. So what is Amazon Aurora? So before we try to understand what this is, let's have a bit of a background here. So as you might be knowing, we have a lot of MySQL flavors. So MySQL that is probably released by Oracle, MySQL by MariaDB, MySQL by Pocona. So we have a lot of things. That's because MySQL is open source. So Aurora is built on top of MySQL by Oracle. So we have made use of MySQL by Oracle and built our own proprietary database so that we get the speed and availability of high-end commercial databases, and yes, simplicity and cost effectiveness of open source databases. Because we're making use of the open source database in the backend.
Refresh the screen once, so it's
yes, understand.
Refresh.
Can someone confirm whether it's better now?
Yeah, it's better.
No.
Thanks, Niranjan.
I'm just moving between the slides just to see if it's causing the issue again. Let me know if it's causing the issue or not. Is it causing the issue again?
Yeah, it seems to be distorting the minute you move out. Maybe you can disable incoming streams, and if that doesn't work, disable outgoing stream as well. Video.
Okay, probably I'll do that. I've just turned off my cam. Is it still distorted?
It's still distorted, Niranjan.
So you may like to run it in non-presentation mode, Niranjan, if that doesn't work. Presentation mode doesn't work.
Okay.
The other option could be if somebody has the slides, they can run through while you're presenting.
Yeah, it's about to slow down. That would help.
So guys who are on video, maybe if you can switch off your video for a while, let's see whether that makes a difference for the presenter.
Niranjan, if it works for you, you may share the slide deck with me on the Slack and I can share the same.
Yes, I'm doing that. I'm just checking one last thing whether this is going to work. Is it better now?
Yeah, now it's clear.
Yep.
Much better.
Awesome.
Oh. Okay, sorry for that. Yes, coming back to where I started. Maybe I can even try turning on cam. Let me know if that's going to cause issues. Turn off my cam. Okay.
Can you go back to the previous one and start from there, please?
Sure. Yes. So I was just speaking about what Aurora is, and had explained about the different flavors of MySQL that we have. So one is the one from Oracle, the other is from Pocona, and we have MariaDB. And Aurora is built on top of MySQL that is built by Oracle. So, since it's an open source, we are building it based on an open source system. You're going to get the simplicity and cost effectiveness of an open source database. But yes, considering that we are modified and we're giving you the benefits of RDS, you're going to get the speed and availability of high-end commercial databases. And it's compatible with MySQL and PostgreSQL, but then this session is going to like majorly focus on Aurora MySQL. And as it is for any other RDS service, you're going to pay as you're going to like use it. So starting with the architecture. So this is your Aurora cluster where you have a common storage, and the common storage is made up of 6 storage nodes, which is spread across 3 availability zones. Availability zone A, B, and C. So you have 2 data copies or the 2 storage nodes in each of the EZs. And you have the database nodes. I'll come to this in the upcoming slides. So we have something called as primary nodes and the replica nodes, which is responsible for performing read and write. And it's going to happen from the common storage volume that's here. Okay. And each database page is around 16 KB in Aurora MySQL, and any write is considered as 8 KB here. So the 2 types of DB instances that we saw in the previous diagram, it's the primary DB instance and the Aurora replica. So we only have one primary instance in the entire cluster, which is responsible for performing writes on the cluster. So it's going to make writes to the storage volume, and the Aurora replicas are reader instances, are going to help you with read activities, and then it's going to read from the same storage volume with minimal latency. And Aurora replica, it's not just for distributing your reads, but instead it's even acts as a failover target. So whenever the primary node goes down, probably going back to the image here, if let's say that this primary node goes down because of any issue, so one of the read replica or one of the Aurora replica will come up as the primary node, and the previous primary would go as the reader. So the Aurora replicas within the Aurora cluster act as a failover target as well. And you have more control over choosing which replica should come up as the primary. So you have something called as failover priority, starting from 0 to value 15. So 0 is going to be the highest priority and 15 is going to be the lowest priority. You can set the priority that you need for all the reader instances, and based on that, the instances is going to come up as primary when there's an issue with the existing primary. I hope this is clear with the architecture, and I'll be moving to the next slide for explaining how exactly it's different from traditional database architecture. But yes, I'm okay to pause for a moment, waiting for your questions. Okay, I'll take the silence as no.
Niranjan, you mentioned 8K write and 16K read, right?
Yes.
Is that a block size or what exactly is that?
So it's the page size. It's the page in Aurora. Yes.
And it's configurable, I guess.
It's not configurable.
Any specific reason why it's hardcoded in that way?
Okay, so the storage system of Aurora is not exactly same as your normal SSDs or normal block devices. So this is a custom storage device built specifically for Aurora.
So performance seems to be the key reason behind it.
Yes. Yeah.
Okay. So if we have a larger or a smaller database, you don't need to tune this. So it's not tunable at all.
Yes, it's not tunable, but then yes, like I told, writes are going to be less. So anything smaller than 8 KB, we're going to try combining it so that it's going to be a single IO. We try merging the IOs, ensure that you get 8 KB.
So multiple writes will be merged into 8K blocks and then gets flushed. So 8K is a flush size, you mean?
Yes.
Okay.
Okay. Yep, that's correct. Yes, coming to the difference. So I'll speak about the IO, like how exactly IO is different when compared to your traditional system and Aurora. When I say traditional system, I'm speaking about MySQL, probably set up on an RDS system or your on-premise self-managed server. So yes, whenever you perform any writes, let's say inserts, update, you know that in a MySQL system, you're going to write to the redo logs. And immediately when you're done with that, you're going to treat that particular transaction as committed. And after that, the database has another work of probably writing to the double write buffer and to the actual data pages. And if binary logging is enabled for any case, then binary logging is another overhead for IO. Coming to Aurora, it's just writing to the logs, creating the actual data pages, and creating, again, we don't have something called as double write buffer here, but creating the actual data pages and remaining task other than writing to redo logs is all offloaded to the storage node itself. I'll explain how this works in the next slide, but this is how things happen in a nutshell. And speaking about binary logs, though I mentioned that binary logs are an overhead in MySQL servers, it is indeed an overhead even in Aurora, But the catch about Aurora is that Aurora provides most of the features without the actual necessity of binary logs. So you can keep binary logging disabled on Aurora to get almost all the features that are like provided by like MySQL server hosted on your self-managed machine. So explaining the previous slide, so how exactly IO flows here. So as mentioned in the first diagram, we had like around 6 storage nodes, 2 in each AZ, and spread across 3 AZs. So this green color box that you see here is considered as one storage node. And here again, this is another storage node. So let's consider this as something that is increase in size to help you understand what is there inside. So this is your primary database node, which is called the writer. So what it does is it's going to like send log records when you're actually writing. So let it be an insert, let it be an update. It's going to send log records, which is stored in an in-memory queue here. First, after getting it in the in-memory queue, it's going to be returned to something called as an update queue, which is the persistent storage inside the storage block. So once I've returned to the update queue, this particular storage node will send an acknowledgement to the primary database node saying that the writes are complete. So this is more or less same as what you see in your traditional database system, where you might be sending the content of log buffer to actual redo log. And once it's returned to redo log, you're going to get a acknowledgement saying that the transaction is committed. But yes, the difference is after this. So after step 2, anything that happens in your traditional database system is again done by your primary database node itself. For example, the actual building of data pages. So just to give you a brief of why exactly we need data pages, you might be knowing the database can read the actual data from the data pages, let it be on disk or in the buffer pool. So in order to read the data, we need the actual data pages. And the redo log content alone is not sufficient. Though we can rebuild the content, but to actually process your queries, we need the actual data blocks. So considering the traditional architecture, primary database node, that is your MySQL server, itself is responsible for ensuring that it's going to like create those data blocks from the redo log content. But in Aurora, after step 2, everything is offloaded to the storage node. The storage node is smart enough to take the content of update queue and build the data blocks. So this is how it does. So first, after the update queue is updated and after I've given the acknowledgement to the primary database node, it's going to like sort the content and check for any missing nodes from other storage nodes, any missing blocks from other storage nodes. So it's going to make use of gossip protocol to check, okay, what is missing. And once that is done, it's going to combine all these log records and create the data blocks. So this creation is done by the storage node itself. I'm repeating it sort of because that's something that's really significant here. So the logs are combined to create the actual data blocks. And we have regular garbage collection, which is going to remove the stale data blocks. And then we are even going to like have another validation here, which is going to again communicate with PS storage node to see whatever data that we have here is valid. And once we have this data block, even this is continuously sent to S3, and even the logs are sent to S3 continuously. So this continuous backup happens without any impact to your performance. So the main difference, in a nutshell, I'm just summarizing this. In your traditional architecture, all the work of building the data blocks and everything is done by the primary database node itself. But here, it's the storage node which is taking care of it. So how does this benefit? It's going to benefit you by reducing the IO, as discussed in the previous slide. And second thing, it's going to reduce the overhead of your primary database node, because the storage node itself takes care of it. And the third one is recovery. I'll speak about recovery in the upcoming slides where we have a separate one for that. But yes, that's how it works. Any questions so far? This is probably the base that I'm going to use in the upcoming slides. So I'm really hoping here for any questions. Okay, I'll take silence as no. Now, this is the data that we have for IO comparison. So this is based on the test performed before 2019 reInvent to compare the IO performance of MySQL and Aurora MySQL. So we ran a 30-minute suspense test, and we could see that after 30 minutes, we could see 78K transactions were completed and 7.4 IO per transactions were used. But coming to Aurora MySQL, we could see that it was 27 million transactions and around 0.95 IO per transactions. So if you're going to consider a simple math here, like if you're going to consider the total number of IOPS within the 30-minute duration, you might feel that Aurora had did a lot of IOPS, but that's because it did complete a lot of transactions, and IO per transaction is very less when compared to how much it was for a traditional MySQL server. So you can find the same test results on 2019 reInvent video. And this is about IO again. This itself gives you a good picture of how fast Aurora might have run, but yes, the next slide speaks about the throughput as well. So again, a sequence of 250 tables with this many number of rows run on R4 16x large, we could see that was the throughput for MySQL on a traditional system, and this was for Aurora MySQL. We could see that the write throughput is like nearly 20 times when compared to MySQL. Sorry, Aurora MySQL was 20 times when compared to the MySQL on a traditional system. Again, we indeed promise that we deliver 5 times performance. So if you want to understand how exactly we deliver 5 times performance, we have a benchmarking blog that is written, and you can probably look into that. And we had run sysbench test on an R3 8x large instance for Aurora MySQL and a MySQL server with a similar hardware setup with around 5 lakh selects per second and 10 lakhs updates per second. So that helped us get this value, and you can perform this test with the help of that particular topic. Probably I can give this link for you. I'm giving it in the chat window. Feel free to go through this. Yes, coming to the recovery. So this was one of the advantages that I mentioned when I was explaining about the offloading the writes to the storage node. So when it goes to the traditional architecture, so let's say that, okay, maybe we can go back to the image there to understand this better. So let's say that in the traditional architecture, you write to the redo logs, and after writing to the redo logs, your engine crashes, or your database crashes for some reason, or your primary database node is down for some reason. In that case, when it comes up, it has to actually scan through the redo logs and perform all those transactions again to actually build your data blocks. So this is the one of the major time-consuming factor in your recovery in your MySQL servers, because you might have a lot of transactions that have just committed and are just present in redo logs but have not marked an entry in the data blocks. But when it comes to Aurora, if your primary database node is down, or if your engine crashes, or if something goes wrong with this particular instance, your storage node is still intact, because again, storage node is nowhere dependent on the database node to build up the data blocks. So even if an engine crash after step 2, it's just the storage node itself trying to build the data blocks for you. So primary database node is not even impacted because of this. So when the primary database node comes up, it acts as though nothing else happened on the server, and it continues working. There's some amount of work that happens at the volume, but yes, that's very minimal, and that's the reason you'll see that the primary node comes up within few seconds when there's a crash in Aurora.
Niranjan, how about if the storage node crashes?
Okay, so storage node, yes, that's really a good question. So as mentioned here, so we are not relying on one particular storage node. So there can be a single storage node that can crash. If that crashes, we have 5 more, and we have that quorum, and we'll continue to perform, and we'll continue to serve the workload because we have other remaining copies. All are having the same copies of data. If one storage node fails, you have 5 storage nodes still serving your workload.
So the resync between these storage nodes will be automatic, or admin needs to do something on behalf of it?
Okay, so again, this is probably a bit outside the scope, but I'll give you a bit of a base here. So when we are actually performing the writes, we write to at least 4 of the nodes. We write to the 6, okay, I would say we wait for acknowledgement at least from 4 of them. And when we are reading, we try to read from three of these at least to get the actual data. So if any of the node is down, we are going to get the data from the remaining nodes. So, and when we are writing, since we are waiting for an acknowledgement from 4, even if one node is down, we have the remaining 3 which is having the committed data. So that's not going to cause anything. So this is simple quorum for 6 node architecture.
No, my question is, how does the node that has failed recover? Does it require manual intervention, or is there a mechanism for it to automatically recover?
Okay, got it. I'm sorry if I misunderstood your question. So when the storage node goes down, it's automatic. So we have a recovery mechanism here, which is going to check the health of all the 6 storage nodes. It's going to be a bit internal, like what is the exact mechanism that we use. But yes, considering one of the node going down, we automatically check for the health of the other node and bring in a new node if it's needed, or repair the existing one if it's possible.
Great, thanks.
Does that answer your question? Okay, coming back to, I guess the recovery was clear, right? So recovery is fast because you're not going to perform the redo when the engine crashes. So it's really quick. Okay, so I have few more scenarios. So I have few more features of Aurora, but I'll be covering that with an e-commerce example so that you can relate it in a better way. So it was just said the expectation, and to help you visualize this in a better way, let's consider the categories that you see in e-commerce website, something like fashion, electronics as databases, or probably the subcategories that you see as footwear, mobile phones as something like the tables. Okay, and let's say that we have a lot of users browsing through e-commerce websites to purchase something, compare it with a different e-commerce website, to compare between products, compare between categories and stuff. Okay, so this is the scenario that we're going to consider, and let's see how Aurora helps here. So speaking about scaling reads, as mentioned earlier, we have a primary node and reader instances within the cluster. So we have 15 reader instances, up to 15 reader instances within the cluster. You can either have 0 reader instance or 15 reader instances. So all 15 reader instances will be able to serve your read workload. And since they're having a common storage, the replica lag between them is like very minimal. And just to give you an insight, we're not going to make use of binary logs to replicate between the readers. We replicate internally between the nodes and the storage so that all the reader instances get the consistent data. And each reader instance can scale vertically. So you can have a very small instance with probably 2 cores, or you can even have one of the instance running on 24x. And as and when you're adding instances to the cluster, so you can add a new instance, add a couple of new instances, and remove them whenever you don't need it. And that's not going to impact your workload. Again, we give you a black box experience whenever you're adding and removing reader instances. I'll explain how exactly this black box experience can be like achieved. But yes, you don't have any downtime when you're adding or removing instances. And yes, you can probably use one of the reader instances or a subset of your reader instances for different workload. For example, analytic workload, or for a completely different application itself, where it's completely for reads. And I'll explain how exactly you can manage this in the upcoming slides. But yes, reads is going to help you this way. And how is this different from MySQL read replica? First thing, as I mentioned, your MySQL read replica is going to make use of binlog replication. So binlog, as and when you enable it, you're going to get a performance impact on the source. And second thing, you might have noticed how much time it takes for the replication to progress. That's because of the way replication progresses in binlog. So you might have seen lags going from seconds to minutes to even hours. But coming to Aurora replica, since we don't use of binlog and we're making use of the internal architecture itself to replicate between the reader instances, you're going to get just a lag of less than 100 milliseconds. If you're going to like review the metrics, you can see that it's around 25 milliseconds. But yes, it's usually less than 100. But heavy workload can make the replica lag go up to a couple of seconds. But yes, that's something that's high in Aurora, even a couple of seconds. And another thing is there is no limits or theoretical limits on I/O per instance. But yes, the instance have their network throughput limit. So since, like I told, the Aurora storage is not like any other block device or not as same as a simple SSD, we are making use of a network interface to transfer the data from your instance to the storage node. And we don't have any I/O limit, but yes, since each instance have their network limits, if you're hitting the network limits, your I/O workload might be impacted. So one thing to consider is the network limit when you're like performing reads and writes on your server. And as mentioned earlier, Aurora Reader will also act as a failover target for writer node. So if you're going to compare this with a traditional MySQL architecture, so probably you can achieve this with all being set manually. But even if you're going to do this manually, you're going to like experience a lot of lag. You're going to have separate I/O for each and every instance. And even if you're going to have 15 read replicas in a traditional architecture, each of the read replica is going to have a separate storage device. So if you're going to have a 10 TB storage, then 15 into 10 TB is your total storage size, because each replica will have its own storage and each replica will have its own IO. So that's one of the biggest advantage here. And Route 53 is the one that we make use to help you achieve the black box experience. Yes, I'll explain how exactly that will help you make connections to the Aurora cluster. But in a nutshell, this is how Aurora is beneficial when you compare it with your traditional MySQL architecture. So considering the example of e-commerce, let's say that you have probably users just surfing through different categories and comparing products. You know that it's going to be purely reads. So all those type of activities can be redirected to the reader instances in your cluster. And as and when you realize that there are more necessity of reader nodes, you can add up to 15 so that it continues to serve without any issue. And yes, is it something that you have to do it manually? No, we even have something called as reader autoscaling, which you can configure based on the CPU utilization or DB connections on your reader instances. So you can set the threshold that you want, saying that, okay, let's say 60% CPU is my threshold. If you read 60% CPU, add reader instances further. So it's going to be an average of all the reader instances put together. So as and when your workload increases or decreases, the autoscaling will help you add or remove reader instances to your cluster. And again, as mentioned earlier, since your addition and removal of reader instances is not going to impact your production and there's no downtime, you'll see it as a black box experience. So you just see that your application is connecting and it's able to serve all the workload, but at the back end, you might have added more reader instances or removed the unnecessary reader instances. So how do we achieve this black box experience? It's because of the endpoints. So endpoints are nothing but Route 53 entries. So Route 53 entry, to make it simple, it's just DNS entries. So you have something called as the cluster writer endpoint, which majorly and which only points to your primary instance. Primary instance is the writer that is responsible for performing writes. And you have something called as cluster reader endpoint, which points to all the reader instances. And you have something called as custom endpoints, where you can define the entities that belong to this endpoint. Probably if you want to just include these two reader instances, you can include these two instances in your reader endpoint, so that you can use this endpoint for a separate application or a different type of workload, such as analytic workload. An instance endpoint, it's nothing but a simple DNS entry, which is going to point to specific instances. So the instance endpoint for this instance will point only to this instance, and that's not going to be updated anytime. But the advantage of this cluster writer endpoint is that whenever there's a failover, because of the primary node going down or health checks failing or any reason, and if a new primary comes up, this writer endpoint will automatically be updated to point to the new primary. And even the reader endpoint will automatically be updated to include all the new reader instances. And as you have understood, all these instances are going to read from the common storage here. And yes, for promoting any of the read replicas, you can consider giving the priorities, so that in case you have included two of these instances in your analytic workload and you don't want these two to come up as the primary anytime. So you can provide the least priority to these two and highest priority to this instance, so that whenever there's an issue with this primary, to always fail over to this. Any questions here?
Request anyone who is not speaking, please be on mute.
Okay. I'll take silence as no. So probably we can go to the next slide. So is it just the scaling and high availability that Aurora provides? No, like I told. So we even support your analytic workload. We help you use it for a different application altogether, and then yes, use it for a normal workload as well. And let's say that you have, maybe considering this example, let's say that you have two instances for your normal workload. I mean, one primary plus two reader instances for a normal workload, and this particular read replica for a analytic workload. And you probably in analytics, maybe you need a lot of buffers to ensure that the performance is good. So you have parameter groups for each and every instance. So parameter groups are nothing but configurations, engine configurations for each and every instance. So you can configure what is the size of buffers for this particular instance individually when compared to these instances. we have two types of parameter groups in a nutshell. Cluster parameter group, which is common for all the instances, and we have instance level parameter group, which can associate with each and every instances within your cluster. So it will help you like probably come up with different configuration. I would specifically say engine configuration for each and every instance based on your use case. So that's the advantage of having more reader instances. And though it's an OLTP engine, you can probably like do a lot of OLAP not without impacting the other instances. So one thing to keep in mind when you're running OLEP would be something like the rollback segment history list length, which is nothing but the list of undo logs, which is common for even traditional MySQL architecture. So if you're gonna like have a long running query or long running transaction because of your analytic workload, it can just impact your history list length, which can impact your performance. But yes, apart from the undo list, nothing is gonna like impact the other instances within your cluster.
I have one question. If you can go back to
Yes.
the previous one where you had that depiction.
Okay.
So here we have a shared distributed storage volume. I don't know if you mentioned it. It's like what exactly are you using for that storage?
Okay, I'll not be able to like explain the internals of it, but these are like the smart storage built specifically by us for Aurora. So it's not a simple block level storage like you see in EBS, but it's a smart storage made up of multiple nodes. Nodes are the ones that I explained in the diagram where I showed how the IO flows. So it's built on top of that. So we have multiple storage nodes as such. So we have something called as protection groups in Aurora. So protection groups are nothing but a combination of this particular storage. Okay, let's go back to this image. So coming back to this. So all these instances put together, all these storage nodes put together is your protection group. So these storage nodes are protection groups, and we add to having its own cluster storage. So the cluster 1 has its own storage and cluster 2 has its own storage. But the catch here is that the storage of the cluster 2 has initially only the pointers to the first storage. So suppose this particular node tries to read this particular block here. This block is not present in this particular storage because it's still here. So it's going to go here, get this data, and give you that particular data. And whenever this node tries to make any modification to this particular block, and that's when it's going to be copied. So this is nothing but copy on write protocol. Whenever I'm going to write to a block, that's when I'm going to copy it to the new storage. Till then, it's just going to be pointers to the original storage. So in an ideal situation, when you create a clone, though the clone can serve all your read workload, the storage size of your clone will be very close to 0 because it doesn't have any data blocks as of then. So whenever it's going to try to read, it's going to read from the original storage itself. And whenever it tries to write, it's going to make a copy to this particular storage. And post that, whenever it's going to read from this. So at one point, when all the blocks are changed by the clone, it's going to have its own copy, and that's when it's going to be completely independent of the previous storage. So how is this advantageous? So you can use this for testing. Let's say that you want to try upgrading to a newer version of Aurora itself. So you have an older version of Aurora, you create a clone and you get a newer version. It's really quick because you're not actually creating the storage again. The storage is not a copy as of now. It's completely empty. So it's really quick. It comes up really quick, even if it's of like multiple terabytes. Once that is done, you can upgrade your clone. You can do anything like you do it on any other standalone cluster. Upgrade your clone to the new version, perform writes here, perform reads here, test it, and delete the clone. So it will help you come up with a new clone really quick. And second thing is you're not paying for the storage. Even if it's going to be like terabytes of storage, you're just paying for what is consumed by this. And what is consumed by this. You're not paying for the second copy. And once you delete this, even this is gone. And if you want to like probably even try taking a dump or some very big activity, you can probably create a clone, try performing that activity on this particular clone, and that's going to benefit. So the major, in a nutshell, okay, I'm just summarizing. The major advantage of clone is that you're paying very less when compared to a normal snapshot restore. And second, you're gonna get that particular testing without actually creating a new copy of that particular clone. Any doubts here?
So in case you switch over from primary to the clone, or you switch your primary basically for whatever reasons, right? So then it will do a lot of copying, or it will still stay.
Okay, okay. So when you say switch over, I guess you're speaking about probably removing the original cluster. Is that
Right.
correct?
I want to decommission my primary and switch over to my clone now.
Okay. So, I'll probably give a background even there. So you cannot directly switch over probably once you delete the original cluster. This becomes a standalone. And at that time, everything gets copied. So you can probably test this if you're going to have this cluster, create a clone. Initially, this storage volume will be showing as nearly 0. And once you delete this, you can see that the storage size of this continuously increases until it reaches this particular size. And that's when this cluster becomes available. Does that answer your question?
Yeah, so you're basically saying on delete, it would not delete the storage. It will sync it up into the clone in background.
Yes.
Did it? Okay.
Yes.
And then it will completely clean it up. Okay.
Yes, that's correct.
I have a question. Does this cloning work across the account, like in account 1 to account 2?
Yes, you can. Any other questions? Okay. Someone has something?
Niranjan, I guess you'll be talking about the pricing model later on.
Sorry?
I guess you will be talking about the pricing model later on.
No, we have
no.
kept that out, Syed, because it's not a marketing deck.
Okay, sure.
Okay, and Niranjan, little bit of time check.
Yes. We just have like another slide. That's it. That's the last slide coming up. Yes, something that I haven't covered today, but the features that are like supported by Aurora is Aurora Global DB, Aurora Serverless, Aurora Backtrack, and Aurora Multi-Master. We have many more, but then I've just included the major ones. So Aurora Global DB is going to help you set up replication with minimal latency across regions. So you can have 5+1 regions. So that's again beneficial when you have an application that requires minimal latency across regions. Again, taking the example of e-commerce, you have it on multiple regions and probably one in India, one in Northern Virginia. So you can have clusters everywhere replicating internally with minimal latency. And yes, it's similar to how you have reader instances within a region. This is going to be a separate cluster in a different region with minimal latency to serve your application. And Aurora Serverless is something where you don't have to configure the primary node type or the primary node size. And the node automatically grows or decreases in size based on your workload. So we even have Aurora Serverless V2 coming up, which is already in preview. So please keep an eye on that, and that might really help you in many of your workloads. And Aurora Backtrack is something that helps in going back to a point within the cluster. So you do something wrong on your cluster, you probably do perform an incorrect DML and something that deletes your content. You have this backtrack feature to go back in time within the same cluster instead of something like a point in time restore, which is going to create a new cluster altogether. And Aurora Multi-Master, where we have more than one primary node. So in all the examples that we considered as of now was one primary node and 15 reader instances. Aurora Multi-Master helps you achieve more than one primary node so that you can perform writes on more than one. So these are the features that you can probably experiment with, and then we'll see if we can cover this in the upcoming sessions in future.
Okay, so thanks Niranjan. Please check the checkbox where Nishant was pasting a few important links regarding what Niranjan was talking about. And these are references. All these are getting captured in the live stream, so you can get back and see this. So I'll now invite Kiran Bhitalapur for for the remaining part of the talk, where Kiran actually would take us through a migration which Samsung Pay has undertaken from self-hosted MySQL to Aurora. All yours, Kiran.
Thank you, Devanshu. I'll be taking over the screen. I hope everyone is able to see my screen.
Kiran, please be on the video if possible as well.
I'm on the video. Is it not visible?
You're on the screen share, not on the video.
No.
Okay, cool. Give me 1 second. Something wrong. I'm not sure why video is not coming.
No issues, Kiran. Let's go ahead.
Okay. It is on from my side. I am not sure why it is not visible.
Yeah, I'm seeing you join from 2 devices, so I'm not very sure if the other device is a challenge.
Okay, other device is disconnected, so it should work. It's okay. Today I will be presenting a use case story of Samsung Pay. As you have already heard my introduction, I am not going to repeat myself. So, what is the particular agenda of today? I'm going to take you through a user story, or rather than the technicality, I will go through the user story, what happened, why we did, and how we did. We will give a little bit of introduction to what is Samsung Pay, because most of the users may have that question. So I will try to address that, what is this particular Samsung Pay is. Then the problem statement I will try to make. What was the problem with the earlier implementation, and what is the solutions we were trying to find. Why we found out RDS Aurora is suitable for our requirement. Some specifics I will talk about. And I will say what we gained when we moved to Aurora. So Samsung Pay is a mobile application. As you can see the image, it allows you to do the credit card payment, debit card payment in the POS across country. It is not only in India, it is across the world. In most of the countries, it works. We support everything, credit cards, debit card, gift cards, and various wallet solutions like Paytm, MobiKwik, Freecharge, and UPI payments also we enable. So we are having a worldwide presence, and the user base is continuously growing. That is the introduction to Samsung Pay. And you can just now, you might imagine, okay, this application is going to run on multiple regions, have got a huge amount of traffic. So when we were working on this particular, to state it, Samsung uses both Google as well as the AWS solutions. So I don't have any bias towards AWS solution. But to mention, this particular application runs on the AWS. So we are having various solutions. NoSQL is there, distributed RDBMS is there, normal RDBMS is there, time series databases is there in the use in this particular application. The database sizes, multiple TB size databases are there. TBS, the TPS goes through tens of thousands of TPS. Hybrid implementation is practiced. Basically, some are localized, databases, some are centralized database. Particular Aurora consideration was done for one of the centralized database. So it was a singleton database which supposed to serve whole globe. So it has got data over 3 terabyte. We had a huge amount of data coming in. 3 terabyte was the size when we considered moving out of traditional primary and replica implementation. We were seeing a 50 GB growth every day. So 50 GB, if you consider a normal EBS storage, if I allow 1 TB or 3 TB of storage, still within 1 month to 2 months, the things will get consumed. So continuous maintenance is required. That is what the endpoint is. Over 25,000 QPS were reached, and the server size optimization continuously it was happening every uh, every 6 months. You can think like that. The hardware capacity complete adjustment for a database every 6 months is very much big task, because it will impact the whole application stack. Worldwide impact will be there. Finding out when we can perform this activity, that itself will become a challenge. Reliability of replication. We were having a primary and replica configurations. Whenever we do a recovery, we have to take care of this complete replication landscape. We have to move each and every replication to the new primary. We have to make sure they are in sync. If a node goes down, then the recovery of that itself was a challenge, because it is over 3 TB of data. Follow the sun support. We have to have a 24/7 availability of DBS, and skilled DBS are required, because if a person is not skilled enough, he will not be able to recover any kind of node failure. The increasing cost of ownership. When we say follow the sun, 3 DBS are required in each zone. If you consider 24 hours, we need to have minimum 3. 3 into 3 is 9 DBS. 9 DBS for a single application is overkill, and it is too expensive. That is what I am trying to mention here, the increasing cost of ownership. So here is a few graphical snapshot, which is just before the planning to go to Aurora is taken place. You can see at the end there is a dip. That is because that is where we started our moving out from traditional setup. You can see it is a linear graph, but if I take a little bit, what do you say, more longer duration, it is of 3-year duration. If I take more longer duration, it is a exponential curve. It started with 300 TPS. It went to 20,000 TPS in a continuous manner. So you can see two different colors here, green and yellow. Yellow is for the write node, the primary node, and green is for the reader node. When the optimizations were done, you can see the reader nodes gets more than the writer node. It is a continuous optimization, so you can see the fluctuations. Sometimes in the reader node, nothing is written because monitoring was not enabled. So you can see some gaps. Those are all missing monitoring metrics rather than missing things. So when I simplify the architecture, it looks like this. Self-hosted MySQL had got the distribution across 3 zones to give us reliability in the database. We had got 3 replicas, as you can see here. Primary is there, read replica, and another read replica is there. These 3 were serving the traffic, and one more read replica was there, which was dedicated for DR and the backup. So, sorry.
Kiran, looks like we lost you.
Yeah, I'm not very sure if Kiran's connectivity got dropped or some sort of other outage. We'll wait for some moments.
Oh, sorry, my device is crashed. Give me 1 second. I'm rebooting it.
Time to move to AWS instance.
No. It is my laptop. Sorry for that. I did not expect my laptop to crash. Even though it is a good configuration laptop, it crashed. Windows we cannot trust. So it will take a minute or so to come back. I was explaining that. So let me see. It is coming up. Give me 1 second.
Yeah, till the time Kiran comes back, Dinil, you joined late. Would you like to say a couple of words about your team in Samsung as well as your stuff?
Hey, Devanshu and others. I'm Dinil. I work in Samsung Research managing a couple of projects. One is the growth team and another one is the SRE side. Two different projects. One is the early implementation of the people voice and the Q1. Second project is an ads project, which is primarily for the North American market release and the mobile advertising. Transition digital devices, digital out of home, to mobile devices. Kiran is my peer for the media team. And Devanshu was also my peer earlier before moving to media. Yeah, and I'm based out of Bangalore. Yeah, that's it. That's what we do.
Thanks, Dinil. We'll see if Kiran is back now.
Sorry, still again one more time crashed. I don't know. Give me 1 second. I'm just putting it up. It looks like something is running in the startup which is causing it.
Use of the phone if you would like to.
Sure, but PPT will go away. That is the thing. Basically, I was talking about the architecture. Let me continue the talking portion till the time I will try to bring up my screen. So when we talk about the architecture, I was talking about we are having a multiple primary nodes and multiple secondary nodes. The replica, we are having two replica for serving the traffic, read traffic, and we are having one node which was used for the dedicated backup, and we were using the same node to create the DR setup. When we came to Aurora, the similar kind of setup we made. We were having multiple reader nodes, two reader nodes we chose, and we had a single master. It doesn't look like my laptop want to start. Sorry, giving it up on that. So last another couple of slides were there. If I will try to forward it to Devansu, if he can share, that will be very helpful.
Okay, you can forward it to me. I can share it from my end.
Okay, I will share it to Devansu.
Kiran, I natively don't have a PowerPoint, so the better you can share it with Dinil.
Dinil, email ID, please.
I'll ping you. Dinil Anthony at gmail.com.
One single line, right?
Yeah. It's no space, no dots. DINIL.
Sent you. Can you check?
Kiran, please check your phone outbox. Maybe it's kept in the.
It went through. It is unexpected application.
Kiran, we can do one thing. So I think for the benefit of time, what we can do is we can invite Nikit. Nikit can present, and the time it takes to stabilize, by the time you will be stabilizing, and you can bring you back post Nikit, if that works fine for everyone.
We were talking about the architecture, so another 2-3 slides were there.
Yeah,
I will
so
cover it in the.
But once you restore, please please come back. Okay, Nikit, please go ahead and take over the screen, please.
Sure.
So this is the first time that we are having a speaker from NVIDIA, and I'm pretty much sure if we open up for questions, then people may start asking questions when a free version of NVIDIA graphics drivers is available on Linux. But I'm not very sure whether Nikit would be able to answer that. Please go ahead, Nikit.
Yeah. Hi guys, my name is Nikit. So I've been with NVIDIA for almost 4 years now. Previous to that, I was with Yahoo for some time. So now with NVIDIA. So today's talk, what I'm going to present is how at NVIDIA we are using open source tools to better understand or aggregate metrics from multiple Prometheuses from different clusters. That is the major challenge when you're using Kubernetes and you have multiple Kubernetes clusters. So this is a talk on how we are addressing that using some open source tools. So before diving into that problem, I want to just go over typical Prometheus architecture, how it is, so that folks who don't have knowledge in Prometheus gets an understanding before diving into the problem itself. So let me go into presentation. Yeah. So this is the typical Prometheus architecture. So what happens when you are setting up monitoring in Kubernetes is you have exporters which expose the nodes. So these typically run as daemon sets or any particular pod. And each of these exporter pods, right, they have a metrics endpoint exposed. And what Prometheus does is it scrapes these particular metrics and ingests it and stores it in its local TSDB. And the scrape interval retention time based on, it depends on your particular config which you provide to the Prometheus endpoint. So along with Prometheus, you have something called an alert manager, which helps you grouping of alerts, which helps you page people using PagerDuty. Then there's Slack integration in that. All those kind of things Alert Manager lets you do. There's Grafana, which basically helps in visualizing all the metrics from Prometheus. You can use Prometheus operator, or you can run Prometheus independently like this. Just the advantage of using Prometheus operator is if you have any ad hoc rules or any configs, it watches for those particular changes and injects it into Prometheus, and it reloads the config without having to restart Prometheus itself. That is just one advantage of having Prometheus operator. So this is the typical architecture of Prometheus. And one disadvantage or drawback I would say here is Prometheus, it runs in a single pod or a single node, you could say. It doesn't have a heavy within you have adding and all those kind of things. So by default, it doesn't have all those features, but it's still, even without having those features, it still is a very good tool for your K-test monitoring setup. Now, so when you think of K-test monitoring, by default, you think of Prometheus. Why? Because it uses K-test service discovery. So essentially, when your pod comes up with the metrics endpoint and all those things, you don't have to reconfigure your Prometheus. The discovery automatically happens. Prometheus scrapes the data and stores it in your TSDB. But there are cons associated along with that. What there's no HA solution. That means Prometheus is a single point of failure. So if your Prometheus goes down, you're running blind on your monitoring. So that is one problem. But to counter that, you can have two Prometheuses running with the same scrape config, so that it independently, each of the Prometheus independently scrape metrics and stores it in their local TSDBs. But again, we run into the same problem where if one goes down, you'll have to switch over to the other one. So that is again ingress. You'll have to do an ingress change and point it to a different Prometheus. Or in the Grafana dashboard, you'll have to make a data source change so that you're pointing to the active Prometheus. So that is one con, I would say. One other problem is when you start having multiple Kubernetes clusters, right? You typically have Prometheus running inside each Kubernetes cluster. So say that you have around 20 to 30 Kubernetes clusters which you're managing. Then you have 20 to 30 Prometheus instances you'll have to manage. And the alerts might be generating from each particular Prometheus. So it's difficult for, say, a production engineer or SRE engineer to track alerts and all those kind of on-call related issues. If you have to debug, you'll have to first get into the right Prometheus, get into the right cluster, and all those kind of things. And one more drawback is, since you are having multiple Kubernetes clusters, you don't have an aggregated view, or you don't have a way to aggregate metrics. Say that you want a global error rate of your multiple Kubernetes clusters. So that by default, you won't have that. You'll have to have some kind of aggregation on top of Prometheus to achieve those kind of things. So this is the need. That is why we want to aggregate Prometheus metrics. That is when we have two Prometheus per cluster. That is, we want to run Prometheus in HA mode, but we want to aggregate. Since both of the Prometheus usually have almost the same kind of metric, we can just use an average on top of those functions, those two Prometheus, and plot our queries. That is one reason why we want to aggregate metrics. Same thing when we have multiple Kubernetes clusters. And in Grafana, when you're configuring dashboards, it's better to have a single dashboard, single data source, than to have multiple data source for each particular Prometheus. So that is one advantage of aggregating Prometheus metrics. And you can have an aggregated alerting. So as an example, which I gave, you want to have, say, global error rate. If it crosses some 5%, you want to alert. Those kind of things, you can achieve it when you aggregate metrics from all these particular Prometheuses or your multiple Kubernetes clusters. So there's something called Proxy, which is an open source tool. This what it does is it helps in aggregating your Prometheus clusters. So essentially what this is, Prometheus is a Prometheus proxy that makes many shards of Prometheus appear as a single API endpoint to the user. The major advantage of this is it doesn't require any modifications to your existing monitoring setup. It just sits right on top of it. You can set it up, configure to query your existing Prometheuses, and you have it working right away. So I've linked the GitHub here. Yeah, go ahead.
So Nikit, question is, so your endpoint to, you give a URL redirect or from the existing endpoint, or how do you handle? So you create a new endpoint to facing to the proxies.
Let me just share the next slide, which is the configuration, how we configure the Prometheus endpoints. So in that, we can actually see how we can configure, how we can label them, and how it can be used to aggregate.
Great.
Yeah. So this is just a sample configuration. Before going to type, I'll just go to the next slide. So basically, we want to achieve this kind of setup where we have a single Grafana pointing to Proxy, and this Proxy points to multiple Prometheuses in multiple different clusters. So these are 4 clusters. Each cluster has its own Prometheus, and Proxy is pointing to this particular each of the Prometheuses. So now, how do we do that? Is through the Proxy configuration itself. So this is very similar to the Prometheus configuration itself, because Proxy is built using the same code of Prometheus. Just that the only difference is Proxy doesn't have its own local TSDB. It just queries its children Prometheus and does an aggregation on top of that. So how do we define it? So in Prometheus itself, you have static configs. So similar to that, in Proxy also you define static config, where you provide the targets. That is each of the Prometheus endpoints which you want the Prometheus to aggregate. So here you have cluster 1 Prometheus, right? So in the same config, you just have to point the endpoint of that particular Prometheus, and you have to label the Prometheus saying, okay, this Prometheus belongs to, say, either which cluster. It could be a cluster, it could be, say, a project. You might be handling multiple projects, so you might want to aggregate based on at a project level. You want to aggregate Prometheus. So labels help you do that. So you can define any number of labels based on your need. So for now, I've defined a cluster, I've defined a project here. Similarly, if it is a HTTPS, you want to have TLS config enabled here, you can do that as well. It's very similar to the Prometheus config. So you can use the same here. There's one more, something called ignore error equal to true here. This is one important thing which you should keep in mind when you're configuring this thing. So say that you have these 4 Prometheus clusters belonging to a same project called ABC. Now you want to aggregate metrics over this, say that you have a global error rate you want to calculate with the help of Proxy. Now each of these clusters are giving you some value, and you'll do a sum on top of that and you'll get the availability or say error rate. But say that one of the cluster is down, this 4th particular Prometheus is down. In that case, what happens is you'll get metrics from these 3, but you won't get from the last one. So in Proxy, you're giving to the end user, you're giving a false error rate, saying you're calculating it only from 3, not 4. So instead of doing that, it's better to show it as an error rather than showing it as showing a false data point. So for that particular thing, you have this ignore error true. So if you have ignore error as false, then it will essentially, if one of your Prometheus is also down, then it will show an error rather than showing a miscalculated data point. So it basically depends on your use case, whether you want to have error ignore true or false. So, but yeah, thing to keep in mind when you are configuring Proxy. So essentially with that kind of setup, you can have, so this is at a cluster level. You have multiple clusters and a single Proxy. So also Proxy is stateless, so you can have multiple Proxies itself for HA of Prometheus, HA of Proxy itself. So if you're running Proxy in Kubernetes, so you can have say a deployment with replica set of 2 or 3 based on how much ever CPU it is using and how much ever CPU you can add. So now that was at a cluster level. Now say that you want to aggregate it at a colo level, or you want an aggregated view of all your colos. You could have 6 colos, 7 colos, and you want to have an aggregated view of that. So we just take the setup which we had previously and introduce another Proxy and point that particular Proxy to the Proxy at a cluster level. So you'll have like a tree setup where you can, so essentially Proxy can point to Prometheus or Proxy itself. So you can, with that model, you can have an aggregated view or a single view for your whole data center or your whole all projects essentially. Yeah.
So Nikit, question, even if you go to the previous slide, there is a Proxy as single point of failure. So
yeah,
how do you manage that?
Exactly.
For the Grafana,
Yeah, Grafana is just a visualization tool. Even you can have Grafana basically multiple replica sets of Grafana and just have a load balancer on top. That works as well. So, but same thing. All the except for Prometheus, whatever you are running here, right? Those are all stateless. So you can have replicas, multiple replicas running for both Proxy as well as Grafana. Devanshu.
Okay.
Does that answer?
Great. Thank you.
Yeah. So now coming to performance of Proxy, what is claimed is Proxy's performance is equivalent to your slowest Prometheus. So say that you have 3 Prometheuses here, your third Prometheus basically has a higher query latency. So it takes, say, for a particular query, it takes some 3 seconds. And these two Prometheuses reply in 1 second. So the performance of Proxy is equal to the performance of your slowest performing Prometheus. So essentially, if all your Prometheuses are fine, Proxy queries it. It doesn't take much time to query. Since it is just an aggregation tool, it just queries it and gives you an interface, provides the data to Grafana. So that is about Proxy. Now coming to alerting rules or recording rules. So you all know that you can set up rules in Prometheus and send it to Alert Manager directly. But as I said before, Proxy doesn't have a TSDB to store its own metrics. So in case you want to have alerts here, there's something called a remote write endpoint on Proxy, where you can send it to a TSDB. The metrics has to be sent to a TSDB. So that can be configurable. It can be any TSDB. You can use Prometheus itself as another, along with Proxy, you can have a side Prometheus where you can write to that, or you can have some kind of InfluxDB, any particular TSDB, you can have it so that it can write to that particular TSDB. And you can, so you can have your recording rules or your alert set up on Proxy, which reads from that TSDB and sends you notifications or pages you, those kind of things. Let me show a quick demo for that. Yeah, before I'm just showing, for now, I'm running Proxy in a VM instead of running it in a container just for the purpose of this demo. So I'll just show the config here. So you see, it's just, we are running the binary with the config file. I'll show you the config file, what we're running. Yeah. So what I'm doing is, I've configured 3 Prometheuses. So in the same VM instance, I'm running 3 Prometheus instances. So on different ports. So I have on 8081, 8085, and 8083. So I have 3 Prometheuses running, and for each Prometheus I have labeled saying this is Prometheus and Prometheus 1, and this is cluster and cluster 1. So similarly, Prometheus 2, cluster 2, and so on. So this is the configuration, and I've started running Proxy already. So let me take you to the UI. Yeah, so this is the UI for Proxy as well. So since, as I said before, it is written on top of Prometheus, it essentially has the same UI. It provides you the same features here as well. So in case you want to say query for some metric called go routines. So now you see that it queried all the 3 Prometheuses and gave you a result here saying, okay, go routines, this particular metric from these particular associated with these labels have this value. Now it's very easy to, before doing that, let me just show a graph. You get the same features as that of Prometheus, where you can visualize it locally here. And now it becomes very easy to, so say that you have in each cluster, you have 2 Prometheuses running. So in that case, what you could do is you could just do a sum or average by cluster, so that so this solves your HA problem, wherein it is, if there are deduplicates, it is deduplicating as well. And you have a single data source for Grafana where you can provide, if you want to query at a cluster level, or if you want to do a sum across the clusters, that also, if you just remove the cluster, you should be able to get the total sum as well. So essentially, it helps you achieve better aggregation results using some kind of tool like Proxy. Yeah, so this is my Proxy view. If I go to Grafana, so similar to how you configure your various data sources, you can configure your Proxy data source. So you see the Prometheus data source you used to configure like this, based on what kind of authentication you use. It could be basic or TLS, or you might have some kind of proxy sidecar container running. So you could use that as well. So in our case, since I'm just running it on a VM, I don't have any authentication enabled here. I've just configured it to query on a HTTP endpoint here. So that is how you do it once in order to create a dashboard. So here you see, right, if say that I had to use just the Prometheus, I'd have to have 3 data sources pointing here. Then I'd have to do query for each particular data source. I'd have to make independent queries. So now necessarily with one query, I'm achieving the same result just pointing to my Proxy database, Proxy data source. And this is an example of the SLI across your 3 Prometheuses which I've done. So you should be able to aggregate as well as display individual clusters. So now say that you want to just query for cluster 1, so that can also be done. You just have to query for that particular thing. So now if I do cluster 1, it should just essentially show you what you're querying for. So you can play around with labels and help achieve what you want to achieve with this. So coming back to the slide here, that was the demo. Now a couple of use cases which we are using it, and it helps us solve that kind of issues. We have alert aggregate. We are doing alert aggregation using the same, because now at NVIDIA we have a lot of Kubernetes clusters, and the on-call wants, whenever he logs into his shift or he's taking up some on-call responsibility, he wants to know what are the existing alerts right now. And so that I can start dealing, instead of looking at each Prometheus one by one, you can directly go to your Grafana, query for alerts, look at what is happening in each particular cluster. And based on what you want to do, you can take action on your critical warning info kind of alerts. It helps you identify everything at a single place instead of reaching out for multiple places or multiple clusters. One more thing we do is we have like a node availability dashboard where we essentially keep track of which core nodes are basically not reachable or they're in a bad state, essentially using the same across our data centers. We do that. So you see here, these are say multiple data centers, and you are querying for the node health metric, and you can see few of them are down. So that essentially you need to fix. It gives you a bird's eye view of how your systems are behaving. Yeah, that is it from me. If you have any questions, feel free to.
So any load idea, like what is the load that the current cluster which you kind of mentioned is serving? Say how many metrics are getting piped to the Prometheus clusters from the Kubernetes clients?
Yeah, so that is a good idea, good question. So right now, in our largest cluster, we have around 8 million metrics, and we are using, I mean, the cardinality is 8 million metrics, but when we are querying for using Proxy, right, it doesn't matter how many metrics you are storing in Prometheus. It just depends on what kind of query you are doing. Say that you're just querying for a counter, then it essentially is a very fast metric. But say that you're doing some kind of joins on your metric, on your query. So that would increase, the query latency would increase because you're doing joins from multiple metrics. So because of that, you would probably see a query latency, but not just pulling it. Essentially, you would have the same performance when you are querying from a Prometheus or a Proxy service itself. The same, ideally you should have the same kind of performance. Maybe if there's some network lag between, that might affect your latency that way.
Okay. Thanks for the answers, Nikit. It's quite reasonable. Anyone else have any questions for Nikit? Please go ahead and ask.
Nikit, I have a question.
Okay.
When you mentioned in the earlier slide, first or second slide, Prometheus writes to its own DB. Correct. But it also supports the time series DB. Did you check it out? That is my question, because Influx DB is a highly available cluster type of time series store.
Yeah.
So that might have solved your high availability issue of Prometheus, because DB means you can read from multiple Prometheus, same data you can read.
Yep. So we did use that as well. We did use InfluxDB also for our Prometheus writes. But from a performance side, we were not really happy with the performance which we were seeing. So hence, we decided to go with the Prometheus local TVSDB itself, Kiran. Because of the scale of metrics we were having, we were not really happy with the performance, query latency, and all those kind of things. Yeah, probably later I can share some benchmarking metrics and give those metrics, but right now I don't have it in handy. But yeah, that was the reason why we didn't opt for remote write using Prometheus into InfluxDB.
Okay.
Yeah, I think this is a very pertinent. I was excited to see this talk because generally that was the major problem of adapting large-scale adoption of Prometheus. And if we have a solution right now, which works, I mean, it may not work for all the use cases, but it has worked for one use case which we could clearly see has been deployed in production. Then there are thousands of other revenues which can come up in future. Great, thanks, Nikit, and thanks. Nasir, for reaching out because you are part of the core group since beginning. So thanks for getting NVIDIA onboarded to the LSP Meetup forum.
Thanks for the opportunity, Devanshu.
Okay, so we'll get back to Kiran first. Kiran, are you ready, or Dinil will be sharing the deck and you will be talking?
I'm ready. I will share my deck.
Okay, thanks. Please go ahead.
Is my screen is visible?
Yes, you are up.
Okay. Basically, I was in this screen before getting troubled by the Windows. I was explaining the architecture before moving to Aurora. I was trying to explain the replica, which is here, which is writing to DB replica, which is a cross account one. We were having a encryption everywhere. Okay. Anything is going out has got the encryption mechanism, so that overhead always was there, the encryption over the network. So the read replica had got a problem of latency. So latency was around 600 milliseconds. Our requirement was on the writes and reads. We were having around 300 milliseconds for the writes and below 100 milliseconds for the reads. So this particular replication was set up, and our read replicas were able to give less than 100 milliseconds for the reads, and writes were at 300 milliseconds. So when the load increases, our write performance was going down. The IO requirement by the MySQL was very high. We were unable to scale up. So that was one of the primary reasons where we considered the Aurora, because it has modified the MySQL's storage engine layer. When we looked into the storage engine layer where the changes were done, it is noticed that there are a couple of improvements. Niranjan covered most of the things in DBS terms. It removed binlog sync. So binlog sync and the block sync, whatever sync calls goes to the OS, they have been reduced to minimal extent. And another advantage was at that point in time, we were able to grow to 15 TB. So with those two in consideration, the Aurora migration was considered. When we set up the Aurora, we made sure we are having a write cluster and read cluster, as it gives a read cluster capability. We added 2 nodes in the read cluster similar to whatever was existing, and it provided one more opportunity for us to have a DR. We started to do the DR through the snapshotting. So as we were having the snapshots, we were okay only for the DR. We had got a downtime requirement of 24 hours. So we just put a snapshot sharing across the account so that the replication will continue. As you can notice, we are having a zone failure protection. Because any one zone fails, then the other zone we will make it master, promote it, and we go ahead. You might have noticed our consideration was for the write, because 300 millisecond is very small in the generic terms. If you see, it is a very small amount of time. But when we came to Aurora MySQL, it was giving us below 100 milliseconds. So that was the great achievement we could say with Aurora. What and all it achieved for us? Basically, the hardware maintenance itself offloaded to AWS. They were become the responsible for availability of those machines and make sure if one node goes down, other nodes are available. Growth up to 14 TB was there. It was 2 years back. Now it is 128 TB, which is massive. Scaling out of read cluster become too easy for us because our load was growing in an exponential way. So right now it is around 75,000 queries per second. That is the load on the database. In that, around 40% will be writes, 60% reads. So those 60% reads are served from two of the Aurora. The write speed considerably loud. I mentioned the metrics there, whatever was there. It was around 250 millisecond. It came down less than 50%, 120 millisecond, less than that we started to see. No code changes were required. That was the major thing which we were looking for. We don't want it to involve the developers to do any kind of major modification to code. Otherwise, it will increase the testing time. So the native MySQL support, the whatever existing code base, we just pointed it started to work. Only in few join case, we run into 20-30 tables join. So in few of them we faced issue. We just tweaked the queries to make it work. Nothing much we did there. Skills required by DBA is reduced to a greater extent. One DBA in each region was sufficient. So that is what the reduction it brought down from 9 dBA requirement to 3 dBA requirement. Recovery time reduced drastically. And this auto failover, when it happens in the traditional MySQL, we have to make sure the recovery of the slave nodes or the master node, whichever is failed. So those things drastically reduced, the efforts were reduced. That was my last slide. Any question, I will try to answer.
Yeah, I'm not seeing Girish there. I mean, probably he had something else to catch up, so he moved on. So I'm sure he was waiting for this story. Thanks for sharing this this migration story, Kiran, because this is very important. We can talk about product feature and all, and how it works, how it's built for reliability, how it's built for scalability. But unless we get a user experience, that what was done at a user end, something like so busy a DB of Samsung Pay's scale, the general confidence are not built. So I think this made perfect sense. So thanks a lot, Kiran. Thanks a lot to Nikit and Niranjan for these in-depth discussions. So those who are still here, I think around 20 of us here, and four are on live stream viewing. So we had roughly around 32-33 attendance today's meetup. In a short notice, we published this meetup, so I expected this to happen, and it's good. We changed the pattern of the meetup a bit. So the first talk, if you have noticed, was too in-depth, but I think this forum needs discussions which goes deep at times, and I think it helps. We used to do 3 talks with 3 speakers. Instead, we did 2 talks with 3 speakers, today. So we kept the pattern same since the beginning of our virtual sessions. We'll try to do some more experiments coming in future. If that matters a lot, do provide us some feedback on the Meetup channel or on the Slack group if you are still there. And if everyone who are still there come on the video, I can take a screenshot and close the session for today. Jiva, Sayed, so everyone please be on the video so that I can take a quick screenshot for all of you. So let's see if I can change. Abhijit is okay, he got dropped, so he's adding now. So I think we can take this. Okay, thanks everyone for joining today. We had a nice Saturday morning with all of you. So we'll get back in on March 26th would be our 42nd meetup. So you can mark your calendar for now. We'll receive the invite if you are already part of the Meetup community. Thanks everyone.
Thank you.
Thanks, Dipanshu, for running the show for the past 10 years. That's off to you.
It is great to see 10 years it carried on. So,
yeah.
No,
We'll run for another 10 years for sure.
Yeah.
Thank you.
I hope so.
Thank you, hosts and speakers.
Thank you.
Thank you all.
Thanks, everyone.
Thank you, everyone. Have a great day.
Thank you.
Thanks, guys.
Thanks.